Alright, hello everybody. My name's Nick. I graduated from the Faculty of Kinesiology and Physical Education at the University of Toronto. There I became heavily interested in biomechanics and ergonomics, especially the ergonomics or the biomechanics involved in ergonomics. And I took many extra courses in biomechanics and advanced biomechanics. So it's a difficult subject, and whenever you have problems, especially with math and physics or chemistry, you go on YouTube. I found that there were no exceptional videos or tutorials on how to approach biomechanics or inverse dynamics problems, and also other problems relating to the mechanics of the human body. So this is why I am making a tutorial vid on how to solve inverse dynamics problems. So this is going to be more along the lines of advanced kind of biomechanics. However, I will be tackling some of the elementary problems that you will need to know to get to this step. However, I am doing this first because it's really difficult to understand. So and I know that all advanced biomechanics work is surrounded or involves this inverse dynamic approach. So you know what? I'll make some more videos on the elementary stuff, but for now we'll get straight into this inverse dynamics problem. So before we tackle the problem, we have to understand what it is asking, and I did not write that down, so I will right now. So solve for y of h, x of h, and net joint moment. Okay, before that, so inverse dynamics. Before actually solving the problem, we have to understand what inverse dynamics is. And this is an approach that is used when we have accelerations and other kinematic variables and values. And what we do, we incorporate those. We take into account these accelerations, work backwards in order to find out the forces, the y of h's, the x of h's, and the moments, so the net joint moments, which cause these accelerations to occur, or these accelerations to occur. So that's what inverse dynamics is. It's working backwards to find out what caused the outcome. And before starting, a lot of professors, they're really picky on this. I know a couple of mine were. It's the convention system. I don't really understand why, because a lot of people use a common convention system. However, it's always good to add that. You don't want to get marks off and you got to go argue with your TAs and all that kind of crap. But you must define your coordinate system. By that I mean this. You have to tell the marker which way you want as positive and negative. It is actually fairly important. So this is the common one that is used, and I suggest that everyone uses this. Please write this down on your paper somewhere, always before you start a problem. Up is positive, counterclockwise. Up is positive, right is positive, counterclockwise is a positive moment. Alright. I'm going to go ahead and assume that everyone knows what a moment is and how to calculate moments. And if you do not, I will upload more videos on those things, but we'll get straight into this. Okay, so let's start off by trying to calculate the force at the hip. So this is the hip. And this is, remember, it's the thigh segment. So from the hip, then we have the next joint is the knee. We could just put knee. Yeah. Alright. So we got that down. So we're going to calculate this bad boy. And we are going to use Newton's second law in order to solve for the forces in the x direction. So remember, this is a dynamic problem. So the forces are equating to an acceleration that whose value is greater than 0, because it's not static. Static implies and infers that the acceleration is 0. Here we do not, because bam, dynamic. Alright, so the sum of the forces always start off like this. In the x direction is equal to m, the mass, ax. Mass is right here, it's given to us as 4.8 kilograms. However, if it's not given, if the total body mass of the person is given, you take the total body mass and you will be given a chart, a proportionality chart, and you multiply the proportionality of whatever segment is in question by the total mass to get the mass of that segment. In this case, it's a thigh segment. So, the sum of forces in x direction. What are those? So we're given one here, 20. And it's a sum, sigma, 20. And we are trying to find this, and this contributes to the total force in the x direction. So we're adding x of h. And we draw our unknowns always as positive. It just makes the mathematics a little easier. And we know that it is equal to a mass of 4.80 multiplied the acceleration by 2. So this, a little simple multiplication here. So we have 20 plus xh is equal to 9.6. We are trying to isolate for this. Carry this over here. So x of h is equal to 9.6 minus 20. This was equal to negative 10.4 newtons. Hopefully you can see that there. And now we're going to do the same for the y direction. So the force is in the y is equal to m(a)y, right? So what are the forces in the y direction? So we have 50 here. The force of gravity acting on the segment. Do not forget this. And we know this is always acting down, so it's minus, right? Or if you want, it's an addition, so it's plus minus 40. And then we add in our unknown. This is equal to 4.80 multiplied by 4. And let's do this up quick. My calculator here. So we know this is 10 plus YH is equal to 19.2, but let me verify this with the calculator. 19.2. Carry this over. So YH is equal to 19.2 minus 10. And well, I didn't need a calculator for that, but yeah. So 9.2 newtons. Bam. First step done. Okay. So kind of go over. Make sure you've added in. Like, go over your calculation, make sure you add in every force that was given to you. So here, in the y direction, force of gravity, the force at the knee. In the x direction, it was just force at the knee. And isolate and solve. And this is what we have got. The next step is calculating the, oh, sorry about that, keep hitting the camera, the net joint moment. So, a little introduction to what a moment is. So I'm going to try to keep this in the picture so you see what we're doing here. So a moment is defined as a force. It's a product of the force multiplied by its perpendicular distance, called the lever arm or the moment arm. So a moment causes angular rotation, and whenever we're talking angular rotation, we kind of substitute moment as a force. So in linear motion, a force is equal to some mass multiplied by an acceleration, as we know as Newton's second law. And in angular terms, we can equate this to a moment is equal to the mass moment of inertia, and I will get into these specifics in other videos. I'm just assuming that everyone knows what this is. This is the distance the mass is spread about the radius of gyration, or the center of mass, sorry. And the angular acceleration, because angular motion is being caused by a moment. Okay, so that is equal to that, that is equal to that, that is equal to that. This is linear, and this is angular. Okay, so now, so we know a moment, the sum of all the moments is equal to I. We have I over here, it's given to us on the other page. Sum of the moments is equal to I A. Right? So we could just, for simplicity's sake, we can multiply them over here. So we have -3 angular acceleration, radians per second, multiplied by 1 kilogram meter squared. So it's equal to the moments that we are going to take into account. Extremely important that you pay attention to this part. Understand that the moment is equal to the perpendicular distance multiplied by the force. So this is the point at which the segment is rotating on, right? So let's, for example, say if we're taking first into account this force, the 50 Newton, right? It's pointing up. So take your pen. This is a very effective method. If you're applying a force up, it's creating a positive moment, right? Bam. If the segment's like this and you're pushing on it this way, it's also creating a positive moment, right? So we'll take it one step at a time, and we'll take into account the 50 that was given to us. So the force multiplied by distance, force 1 dot, and so on, plus the moments given to us, the actual moments, right? So -3 is equal to, so we'll do 50 first, multiplied by the perpendicular distance. What is this perpendicular distance? We're given some lengths here, right? So from the point of rotation, which is at the hip, we add these lengths together, right? Because it's the whole perpendicular distance, since the rotation is occurring at the hip. It's imperative that you understand where the joint or the segment is rotating about. Please read the questions. They're going to have different points of rotation. Understand where, and you pin it. And then so you apply the 50 up, right? So 50 multiplied by 0.45 meters. That's one done. So we know this creates, you can bracket this and we know, you can put that creates a positive moment. Add 20 newtons multiplied by this perpendicular distance. So we know that this is acting in the x direction. Perpendicular to the x direction is the y direction, yeah? And we have these distances here. They're the distance from the knee to the place of rotation, right? And it's perpendicular because even if you want to extend the vector here, you could put this as 20, and what do you know? It's perpendicular. So this is multiplied by 25.25 meters. Always convert to meters as well. A lot of my profs, they, of course they try to throw you off by putting centimeters. Just simply convert it. Plus that. Another moment that we have to take into account is the one due to gravity. So this is the center. Right. So say if like this, and it's, whoops, can't see that, and it's pulling us down, right, straight down. So this is creating an, bam, you see, it's going clockwise, so it's creating a what? Negative moment. So add 40 by the perpendicular distance. So from here to here, because you extend the moment or the vector of that force and take into account the perpendicular distance, 0.20, right? And this creates a negative. Note that it's a negative moment that it's creating. Minus, we're given 10 Newton meters here. And then add our unknown net joint moment, because this is the sum that we're looking for. So we have to take into account all the moments. So let's do this up quickly. My memory card is running out of time. I only have 2 minutes. Okay, so we have 50 times 0.45. So negative 3 equals 22.5, and this is a positive moment. So 20 times 0.25 plus 5 minus, because we know this creates a negative moment, 40 times 0.20, so negative 8 minus 10 plus net joint moment. So we'll have, if we add all of this, so the net joint moment, you carry over everything, or we could just add these up here, 22.5 plus 5 minus 8 minus 10 gives us 9.5 equals negative 3, carry this over, net joint moment equals negative 9.5 plus negative 3 minus 12.5 Newton meter. And there you have it. This is how you do sort of a simplified inverse dynamics problem. Understand the steps, and you will understand what you're doing, how to apply your perpendicular distances. That is imperative. Do not forget this, because it will, cause you to lose marks. And here's the whole problem again. First step, calculate the forces. Know that it's dynamic. And then calculate the moment, the total net joint moment, and know where your point of rotation is. And thank you for listening. I will upload some more videos on the elementary stuff, but please, I'm open to constructive criticism, of course. This is my first video. I really hope this is helpful, and I wish you guys the best of luck. If you have any other questions, please email me, and I will try to do tutorial vids on it. I am going to school as well, so it will be kind of busy. I'm just, on winter break, and I'm trying to get as much as I can done. So here you guys are, and enjoy.